Last thing we're going to look at in our little bit of a look at coordinate geometry is a specific type of question. How do you find the equation of a line when what you know is it passes through a particular point, but also the intersection of another two lines? So here's a typical question. Find the equation of the line that passes through the intersection of these two particular lines and the point 1, 2. Now I suppose the first instinct is, well, let's go and find this point of intersection. So we solve them simultaneously. We want to make the coefficients the same, x or the y. I went for the y, made them both 5y. So let's subtract. 7x is negative 14, x is negative 2. We can sub back in and we get y is 3. So I now know 2 points. Oh, well, if I've got 2 points, I should be able to find the equation of a line. Because in order to find the equation of a line, we just need two things, a point and a... Oh, we haven't got a slope. However, we do have a formula that will allow us to find the slope. So we have our point of intersection and the other point they gave us. Using our slope formula, we now know the slope is minus a third. All right, so point slope formula, y minus 2 minus third x minus 1, and eventually we get the equation of a line. And I suppose that would be the logical way of thinking about that. There is another way. It's what is called the lambda formula, which is quite interesting, seeing the Greek letter lambda does not appear in there anywhere. But the reason I call it the lambda formula is the first time I saw it, instead of it being a k there was a lambda there. So hence the lambda formula. But what we're saying is, look, we know that the point lies on both of those lines. Remember the point of intersection, so it must lie on both of those lines. So it must be true that when I substitute it into the first line, I would get 0. And when I substitute it into the second line, I will get 0. And so therefore, it doesn't matter what k is, it will always be 0. But the question is, what's the other point? And so what we do is we multiply one of the lines by k. And then we can substitute in the other point, so not the point of intersection, and we can work out what k is. So let's try it with that same question. So the two lines, we had 2x plus y plus 1 equals 0, and we had 3x plus 5y minus 9 equals 0. So we just multiply one of them by k. It doesn't matter which one. I've chosen the 3x. They told me it went through the point 1, 2. So I'll substitute 1 in for x, 2 in for y, calculate it out, play around with it a bit, and eventually we get that k is negative 5 on 4. Well, now I know what k is, I can go back and sub it in, and there's my equation of a line. It doesn't look like a line at the moment, but of course I can tidy this up. Multiply everything by 4, get rid of the fraction. Move terms around. 7 actually goes into all that, and there's the equation of the line, same as we got before. So it is a little bit quicker than the process we used before, finding the point of intersection and doing all that. The other method, of course, works, but again, it's playing with the pattern of the mathematics. If we can play with the pattern, we can solve ourselves some time. So the idea is you get both of those lines, one of them multiplied by a constant, and then substitute in the point that you know it goes through to work out what the constant is. And then you've got the equation of the line. You might have to do a bit of algebra to get there, but you'll get the equation. So a nice quick one. The